Okay, so imagine this for a moment. The universe is not hostile, it's indifferent. And that indifference means some of the most dangerous threats to life on Earth aren't science fiction, invasions, or distant fantasies. They already exist. They are already moving, and in some cases, they've already happened. We just haven't seen the consequences yet. Number 10. The Kessler Syndrome Cascade. On February 10, 2009, something irreversible happened above Siberia. An inactive Russian satellite collided with an operational American communication satellite at an altitude of 790 kilometers. The impact between Iridium-33 and Cosmos 2251 produced more than 2,300 trackable fragments, each one traveling at nearly 28,000 kilometers per hour. That's 10 times faster than a bullet. This wasn't just space junk, it was proof that a theoretical nightmare had become real. In 1978, NASA scientist Donald J. Kessler warned that orbital debris would eventually reach a critical density. At that point, collisions would no longer be isolated events. Each impact would generate more debris, triggering more collisions, a self-sustaining cascade. For decades, the idea felt distant, abstract, avoidable. The 2009 collision proved otherwise. Today, global tracking networks monitor over 34,000 objects larger than 10 centimeters orbiting Earth. But that's only what we can see. Estimates suggest more than 130 million fragments smaller than 1 centimeter are circling the planet right now, invisible, untrackable, and lethal. The cascade has already begun. Atmospheric drag naturally removes some debris, but recent analyses show that collisions are now producing fragments faster than the atmosphere can clear them. The process is self-sustaining. Every satellite we depend on, GPS, weather forecasting, communications, military systems, exists inside an expanding minefield we created ourselves. The question is no longer if orbital space becomes unusable, it's whether we recognize the tipping point before it happens. Number 9. The Andromeda Milky Way collision. In 2012, astronomers using the Hubble Space Telescope confirmed something humanity had long suspected. The Andromeda galaxy is moving towards us at 400,000 kilometers per hour. For decades, scientists knew Andromeda was approaching based on its blue-shifted light, but what they couldn't determine was whether it would pass safely by or collide. Hubble's measurements of Andromeda's sideways motion removed all doubt. The collision is inevitable. In approximately 4 billion years, the Milky Way and Andromeda, separated by 2.5 million light-years, will merge. Andromeda contains nearly 1 trillion stars, compared to the Milky Way's 200 to 400 billion. When they collide, gravity will rewrite both galaxies. Stars will be flung into new orbits. Some will be ejected into intergalactic space. Others will spiral inward towards the merging galactic cores. Our solar system's fate is uncertain. Simulations suggest a 50% chance the Sun will be pushed into a wider orbit, farther from the galactic center. There's also a small but real possibility that we could be completely expelled, drifting alone through the void between galaxies. In the worst case, gravitational interactions could send Earth to one of the supermassive black holes at the galactic centers. The result will be a new elliptical galaxy astronomers have already named Milkomeda. Any civilization alive to witness it will see the sky transform beyond comprehension, 2 galaxies tearing each other apart over hundreds of millions of years. The appointment has already been set, and nothing can cancel it. Number 8. The Rogue Planet. In 2011, astronomers working with the MOA collaboration discovered something deeply unsettling: planets that don't orbit stars. Rogue planets, worlds expelled from their solar systems by gravitational chaos, wandering the galaxy in total darkness. The discovery confirmed what simulations had long predicted. During the violent early stages of planetary formation, ejections are common. Stable systems like ours are the exception, not the rule. Estimates suggest there may be 2 billion rogue planets in the Milky Way alone, more planets than stars. These objects move at typical galactic speeds of 30 kilometers per second, their surfaces frozen near absolute zero. They emit no light and are detectable only through gravitational microlensing, brief distortions of background starlight. Some are massive as Jupiter, and we would not see one coming. Unlike asteroids, rogue planets don't follow predictable orbits around the Sun. They arrive from interstellar space without warning. A close pass could destabilize planetary orbits, scatter the asteroid belt, or push Earth out of the habitable zone entirely. Simulations show that a Jupiter-mass rogue planet entering the inner solar system would reshape everything. The terrifying reality is numbers plus invisibility. Billions of dark worlds. Any one of them could be heading towards us right now, and we'd only notice once gravity started pulling the outer planets out of place. At that point, we'd have months at most. Number 7. Betelgeuse's supernova. Betelgeuse, the red star marking Orion's shoulder, is dying. This massive red supergiant, located about 650 light-years away, is massive, unstable, and nearing its end of life. In late 2019, astronomers observed Betelgeuse dim by 35%, an unprecedented event. Speculation exploded. Was this the beginning of a supernova? Betelgeuse is about 700 times larger than the Sun and only 10 million years old, ancient for a massive star. It has exhausted most of its nuclear fuel and now fuses heavier elements in an unstable core. The laws of stellar evolution are absolute. When the fuel runs out, the core collapses and rebounds in a Type II supernova. That explosion could happen tomorrow or in 100,000 years. When it does, Betelgeuse will briefly outshine the full moon and remain visible in daylight for weeks. A flood of neutrinos will arrive hours before the light, ghost particles passing straight through Earth. But the real concern comes afterwards. Models suggest the explosion could damage Earth's ozone layer, exposing the surface to increased ultraviolet radiation. And here's the unsettling part. The light we see from Betelgeuse left 650 years ago. It may have already exploded. If so, the radiation front could already be racing towards us through the dark. Number 6. Magnetar SGR 180620. On December 25, 2004, Earth was struck by the most powerful burst of energy ever recorded from outside our solar system. In just 1/10 of a second, an object 50,000 light-years away released more energy than the Sun produces in 150,000 years. Satellites were disrupted, the ionosphere rippled, auroras appeared at unexpected latitudes. The source was SGR 180620, a magnetar. Magnetars on neutron stars with magnetic fields up to 10 to the 15th Gauss. Earth's magnetic field is 0.5 Gauss. At close range, a magnetar's field would rip atoms apart. The 2004 event was a starquake, a fracture in the magnetar's crust that reconfigured its magnetic field and released a gamma-ray flare detectable across the galaxy. Scientists calculated that if this eruption had occurred within 10 light-years, it would have been lethal to most surface life on Earth. Only about a dozen magnetars are currently known, but they're difficult to detect unless they erupt. Some may exist much closer than we realize, and the 2004 event proved they don't need to be nearby to affect us. Number 5. The Carrington Event 2.0. On September 1, 1859, astronomer Richard Carrington observed a massive solar flare in visible light. 17 hours later, the fastest coronal mass ejection ever recorded slammed into Earth. Telegraph systems exploded. Operators were electrocuted. Some networks continued working even after being disconnected, powered solely by induced currents. Auroras reached the Caribbean. This storm, the Carrington event, remains the most powerful magnetospheric storm ever recorded. Today, we are far more vulnerable. A 2008 National Academy of Sciences report estimated that a Carrington-level event would cause $2.6 trillion in damage. Power transformers would be destroyed, satellites disabled, GPS and communications would fail. We almost experienced this in July 2012.
A Carrington-scale solar storm missed Earth by just 9 days. We survived by timing alone. The sun doesn't care about our technology, and when the next one hits, we may have 15 minutes of warning. Number 4. The awakening of Sagittarius A star. At the center of the Milky Way lies Sagittarius A star, a supermassive black hole with 4.15 million solar masses, 26,000 light-years away. For decades, it appeared dormant. Then, in May 2019, astronomers observed it brighten 75 times its normal infrared luminosity. Sagittarius A star has a violent past. The Fermi bubbles, massive gamma-ray structures extending 25,000 light-years above and below the galaxy, suggest a powerful outburst in the recent cosmic past. If Sagittarius A star enters an active phase, it
could emit radiation along the galactic plane where Earth resides. The exposure wouldn't be instantly fatal, but over decades it could strip our atmosphere and increase surface radiation. The unsettling truth? Everything we observe already happened 26,000 years ago. We're watching history arrive at light speed. Number 3. 99942 Apophis. Discovered in 2004, asteroid Apophis briefly held the highest impact probability ever recorded. At one point, it had a 2.7% chance of striking Earth on April 13, 2029. Apophis will pass just 31,000 kilometers from Earth, closer than geosynchronous satellites. That pass will drastically alter its orbit. There exists a gravitational keyhole just 600 meters wide. If Apophis passes through it, an impact in 2036 becomes inevitable. We won't know until after 2029. If it hits, Apophis would release 1,200 megatons of energy, enough to devastate a region and disrupt the global climate. You'll be able to see it with the naked eye. The question is whether you'll be watching a close call or a countdown. Number 2. A gamma-ray burst from WR104. WR104 is a massive Wolf-Rayet star 8,000 light-years away. When it explodes, it may produce a gamma-ray burst. Observations suggest its rotational axis could be pointed toward Earth. Gamma-ray bursts focus enormous energy into narrow beams. If one hits Earth, it could strip half the ozone layer in seconds. There would be no warning. The light and the destruction would arrive together. WR104 may have already exploded. We simply don't know yet. Number 1. False vacuum collapse. Physics allows a terrifying possibility. The universe may exist in a false vacuum, a metastable state, not the lowest possible energy configuration. In 1980, physicists Coleman and DeLucia showed that a quantum fluctuation could trigger a collapse to a true vacuum. When the Higgs boson was measured in 2012, calculations placed us dangerously close to that boundary. If collapse occurs, a bubble of true vacuum would expand at the speed of light, rewriting the laws of physics. Atoms couldn't exist. Matter would dissolve. There would be no warning. Discovery and annihilation would be simultaneous. The probability is unknown, but not zero, and every quantum fluctuation rolls the dice again. Remember, the universe doesn't reveal its secrets to those who rush. It reveals them to those who know how to look. Subscribe and keep listening to the silence.